Good morning, everyone. In the last class, we were discussing about IPv6. So there we have discussed about sorting of IPv6, right? So in that we have three methods. First is what? Remove continuous sets of zeros, right? Then this we have to remove with what? With single colon. Next is what? Second, remove single set of zero with single zero, or we can say replace, right? Replace. After that, third rule says just remove only single or leading zeros. This is all the three rules that we have discussed, right? Till it is clear? Okay. So next we have to start with the headers of the IPv6. See, these are the fields. Version we have, class we have, flow label, payload length, next header, hope limit, source address, and destination address. So what is the meaning for that? First is version. So in the version, it inform you regarding the IPv6. Fine. So it says that the size of this field is 4-bit, and this indicates the version of the Internet Protocol, which is always 6 because it is we are using what here IPv6. So the bit sequence here is what 0110, right? You know how it is. 2 power 4 is 8, 2 power 3 is 4, 2 power 4 is 2 power 3 is 8, 2 power 2 is 4, and 2 power 1 is 2, and 2 power 0 is 1. So in the middle, if you will calculate, it will get give you 4 plus 2, 6. That's why it is showing you as a 0110. Fine. In the next one, it says about the class. See, the traffic class field indicates that class or the priority of the IPv6 packet, which is similar to the service field in the IP version 4. It helps routers to handle the traffic based on the priority of the packet. Means here classification is being done that the traffic that is present, whether it is voice traffic, data traffic, or video traffic. That's why here it is talking about what? Class of that particular traffic, right? And based on the classes only what it will do? Priority. And this priority will be done based on what? Quality of services. Okay. Now, because we have multiple different types of traffic, no, it is not that always you will be sending only data. We can have voice traffic also. We can have video traffic also. So which one should get the priority will be decided by whom? Quality of services. But in this, it is going to do classification, identify the types of traffic. That's all. Fine. So what is the size of this one? 8 bits. Flow label. Flow label is what? See, it is used to identify the packet belonging to a same flow. Let's say once you have classified that this is my video traffic and rest other are also the video traffic. So what it will do? It will maintain a flow for that. That's why it is saying you here is that packet belonging to the same flow like video call or voice session and helps the routers to handle flow specific optimizations. So once the classes has been identified, once it is being identified, then one by one transmission will take place, and this is called as a flow level. Right? Response, yes or no?
Yes, sir.
Then we have is a payload. What is payload? It is 16-bit field indicates the total size of the payload, which tells the routers about the amount of information a particular packet contains in its payload. Amount of information that is present that has to be transmitted. So minimum is what? 0. And maximum is what? 16 bits. It means 65,535. The minimum payload and the maximum payload in the IPv6. So here it will inform you regarding what? The total size of the data that has to be transmitted. Correct? So one is version where you identify it as like your IP version 6. In the class, you identify the types of traffic. Then in flow label, once it is identified, then flow will be maintained for transmitting it. And payload, the size of the data that is being transmitted over there. Next header, see, like whenever any data is there, so it is going to contain certain header information. So it is having now IPv6 header. Apart from that, what is other header present there? That is called as a next header. It can be TCP also. It can be UDP header also. So that next header is called as a, this field will be called as a next header, and it is going to be 8 bits. So next header indicates the type of extension header, and if present immediately following the IPv6 header. Means apart from IPv6 header, what all the other headers are present there, that is called as a next header. That information will be written in the next header. So example, it is showing you that it can be a TCP or it can be a UDP. Fine. Now, as you know that we have discussed that when we ping, so it is going to have certain TTL values. So in IP version 4, we have the term called as a TTL, whereas in this, it is called as a hop limit. Okay, so it says hop limit is the same as TTL in IP version 4, and it indicates the maximum number of intermediate nodes of IPv6 is allowed to travel. Same thing, how many devices it is going to cross without being discarded. So it says that it indicates the maximum number of intermediate nodes of IPv6 packet is allowed to travel will be given in the hop limit. Hop limit. Size is what? 8 bits. Just basic understanding you have to know. What does each field means here? Source address size is what? 128 bits. The source address in this 128 bits of IPv6 is called as what? Original source of the packet. It means we can say in simple term, it is a sender's address. And destination is what? Receiver's address. So the destination address field indicates the IPv6 address of the final destination. So this are all the fields in the IP version 6 header, right? Version class, then payload, next header, hop limit, and flow label, source address, and destination address. What is the total size of this particular header? 40 bytes. Okay. See, now we'll discuss the features of the IP version 6. See, it says here that it is going to provide you large address space. How? As we know that IP version 4 is of 32 bits and compared to that it is of 128 bits. That's why it is going to provide us what? More large space, right? So IPv6 addresses are 128 bit long compared to IP version 4 32 bit. This allows for like significantly a large number of unique IP addresses that we were getting in the IP version 4. Fine. Now in this, what happens that IPv6 uses a mask concept that is called as what? Prefix length. So based on this prefix length, we will be identifying here the network part and the host part. Then it says here that no need for NAT. With the large address space, network address translation is not required, simplifying the network design and configurations. This is one of the advantages here. No NAT. Then it provides you what? Integrated security. IPv6 has a built-in IPsec support, which provides improved security features over the IP version 4. That's why I told you that compared to IP version 4, IP version 6 is more secure. Fine. It provides you what? A stateless address auto configuration. We'll discuss this. We'll do the configuration also for this. So it is a feature in IPv6 that allows the devices on a network to automatically configure their own IP address without the need for the central server like a DSC. Means in this, what will happen? No, that let's say we are having two routers. Then what happens that on the interface G0/0, we have configured one IP address. Then on interface G0/1, we will not configure any IP, but it is going to take it automatically from where? From this router one. Understanding? We will configure IP address on the interface G0/0. We will not configure any IP on the G0/1, but this G0/1 is going to take automatically one IPv6 address. And this feature is called as what? A stateless auto configuration. We'll, we'll discuss this using the configuration, how it happens. So these are the basic features of the IP version 6. I told you that here also we have different types of IPv6. No classes is there, but types is there, right? So in these different types, like first is what? Global unicast. So global unicast is like what? It is like a IP version for public address. So it says that it is similar to IPv4 public address, and these are unique across the entire internet, and it can be publicly routable. And here it says that it is going to start it from where? 2000 double colon slash 3. Now, what does it mean? It means that any IPv6 address, if it is starting from 2000, you have to identify that it is what? Public. Public IPv6 address. That's why here it is written as what? Global unicast. Now we'll show you what it is, that slash 3 that it is written here. In this, it says that first 3 bits are reserved. Fine. First 3 bits are reserved. So how you will identify this? Now, first you know that 2 power 3 is what? 8. Then 2 power 2 is what? And 2 power 1 is what? 2 power 0. Now, you have to write this 2 into the bit form. How we write this 2 into the bit form? The first letter is, first number is what? 2, no? So 2 you have to write. So 0, 0, 1, 0, 0, 0, 1, 0. Now what it says that first 3 bits are reserved. It means here, this first 3 bits, it is reserved. Fine. It means the last one, that is the fourth bit, is not reserved. We cannot do, we can do any changes over there. So if it is 0, I can make this 0 as a 1 also. So now if I am going to make it as a 1, so what value I will get? 0, 0, 1, and 1. I can change it also because it is telling you that first 3 bits are reserved. If 3 bits are reserved, I can change the fourth one. Fine. So now the value I got is what? 3. Add now, no? 2 and 1, 3. 2 and 1, 3. Right? So now it says that your IPv6 address can be start from 2 also. It can be start from 3 also. Which IPv6? Global unicast. Whenever you will see any IPv6 address starting from 2 or starting from 3, it is IPv6 global unicast address. Got it? Hmm? Same as now you see what it says, unique local address. So these are intended for local communications within a site. It is like a private IP address. So this is like what? Private IP. And how you are going to identify that this is a private IP? FC 00:7. So FC 00:7. Here, what does it mean? That first 7 bits are reserved, right? First 7 bits are reserved. Now, same formula you have to use. First, you will write F. What is the value of F? 15. Now, how we write 15? 1, 1, 1, 1. Now, when you are writing F into the bit form, how many number you have got? 4. But here it is, what is written here? 7 bits, no? So it means 3 more I have to write. So for that, I will again use C. What is the value of C? How will you write? 8 plus 4, 12. It means double one.
Coming back, like classes.
Now see. So here it is written as a like 1100, right? Now it says that first 7 bits are reserved. It means this 4 is reserved and this 3 are reserved. So what we can change? The last one. So if I change the last one, what I will write? 1, 1, 0, and 1. So if I'm writing this, what value I will get? 13, no? 8 plus 4, 12 plus 1, 13. That is what? D. It means I can get it here FC00 also. I can get it here FD00 also. Understood this? What does it mean? So wherever you are finding this one, it says that this many bits are reserved. Correct? So this is my public IP. This is my private IP, private IPv6 address. Then one more we have that is called as a link local address, link local unicast. See what happens now. Devices will be having its own link local address. How it happens, we'll discuss that part, but it is going to get it from the MAC address. Okay. We'll discuss this part. So it is telling you that these are used for communication within a single network. It is also like a local IP only. And it is going to start it from where FE80 double colon slash 10. So if any IPv6 address is starting from FE80, then it is what? Link local address. And every devices will be having its own link local address. See here. It has FE80 and what it is? Link local IPv6 address. There is no any private IP on this particular. What is there? Link local address. How it is getting? We'll do that. Okay. So one is link local address. Then we have what? Multicast address. Like how we had in the case of IP version 4. Same here also, multicast address. So these are used to deliver the packets to the multiple interfaces. And a packet sent to a multicast address is delivered to all the interfaces identified by that particular address. And this is going to start it from where? Double F double zero double colon slash 8. It means here first 8 will be bit will be reserved here. That's why it is telling you as a multicast address, right? And multicast address is used for what? Whenever you have to send the traffic or any particular data information to the multiple interfaces, then we will be using what? Multicast address. Like in IP version 4, which class is reserved for multicast address? Which class? Class D. Class D is reserved for the multicast address. E is for what? Research and development. So, see what it says here. That global unicast, what it is. This is the address that work like a public IPv4 address. Now, the organization that needs IPv6 address asks for the registered IPv6 address block, which is assigned as a global routing prefix. After that, only that organization uses the addresses inside that block of the address. And now it is going to have certain prefix length. So what happens? That let's take we'll take in the example of this one only. See, in this, the first three, this is called as a network part. It means who gives this? Like based on the IANA network part, it is. This is what? This is called as a subnet. We can change this. What it is called as a subnet part. And the last one is what? And the last one is called as a host part. So 48 bit, 48 bits is network part. Then 16 bits is subnet. Then 64 bits is host. Write down some content. ISP provides or provides to customer last 48 prefix This means the first 48 bits are fixed and represent network part. Okay. Next, within the network, the next 16 bits within the network or are used for subnetting, and this allows to create 655,356 subnets. Because what is the size of this? 16 bits. 2 power 16, this is the value, right? No, that's why. So now let's say you have got this network part. So now you are putting here as a 4 times zeros. This is one variation. Then you are putting here 3 times 0, 1. One more variation. Again, 3 times 0, 2. 3 times 0, 3. Like that. Fine. 65,000. Okay. 65,536. And last 64 bit is what? 64 bits are the host part. So imagine one is 2 power 16 variations and one more is 2 power 64 variations. So it means here also I can do the changes. Here also I can do the changes. So the size of the IPv6 address, how many variations you can do it here, apart from the network part. Clear? Now see. That's why it is explaining you that first thing it says that a set of address that only one company can use is called as what? Global routing prefix. That we know that's why it is called as a global routing prefix. Now in the address type, we have one is global unicast. It says that 2 or 3 originally is reserved for what? The IPv6 global unicast. Unique local is for what? FD. Multicast is for what? Double F. Link local is for what? FE80. Now, even you know that there is one more feature in the IP version 6 that is called as what? Anycast. Correct? No? So Anycast is not like a only feature of IP version 6. It can be used in the IP version 4 also and IPv6 also, but mainly in the IP version 6 part. So what is the meaning of this Anycast? What happens in this? It says that these are assigned to multiple interfaces. Means one address will be assigned to multiple interfaces, usually on a different devices, and packet sent on any cast address is delivered to the nearest interface as determined by the routing protocol. What does it mean? Where will you prefer this? Any cast feature? Yes. So we can prefer this particular for the DNS servers or for any particular servers. Let's understand with one example. You want to reach a server. What happened that as there were more traffic that it will be reaching to the servers, that's why we have multiple different servers with the same IP address. IP is same. So whenever you are trying to reach any website, so what happens? It is being redirected. I mean, it is being directed towards a particular servers. Now, what happens that if lots of traffic is coming on a single server, then what will happen? It will not be able to handle the traffic. That's why what happened that we are going to have multiple different servers. Now, you know that if I have to reach a particular domain, it is going to have a single public IP address or any private IP address. So for that, you will be using DNS. So it is going to resolve that IP address. Then you will be able to reach that particular server. But as I told you that more traffics are there, so it is not possible for us to reach a single server, or it is not possible for a single server to handle the multiple traffic. That's why what happens that there will be multiple servers with the same IP address, right? And whoever is the closest, that is going to that will be reachable. If it is not reachable, then what will happen? The traffic will be directed towards next server. Okay, to handle more numbers of traffic, we are going to have multiple different servers. Okay, and whoever the closest one is there, that is going to receive the traffic for the first. Getting my point or not? Imagine there is a one server. Okay, fine. Then this is the client PC. Now, now tell me that if it is going to have multiple different IP address, consider that this is example I'm giving you 2001 2. Okay, this is also like this. Same IPv6 address is there. Now for him, which one is the closest one? A, B, or C? A is closest to, but IP is same. But which one is the closest for him? This one. So whenever it is trying to reach that particular IP, it will be able to reach this particular server, not this one. If it is unavailable, then only it traffic will be directed towards server B. If it is not available, then only it is directed towards what? Server C. Okay. So multiple servers is going to have what? Like a same IP. This can be preferred in the case of DNS. Correct? No? To handle the more number of traffic. That's why this feature is called as a anycast address. So the traffic will be delivered to the nearest node in this scenario. Understood this? That's why it is said as a anycast address. So these are assigned to multiple interfaces on a different devices, and packet sent to anycast address is delivered to the nearest interfaces as determined by the routing protocols. Clear? These are the types of the IPv6. Global unicast like a public, unique local like a private. Then we have a link local, multicast, and anycast. See, this multicast address will be further divided. You can see here that when we talk about the multicast address, so it is telling you that if in the sort, if you want to send it to the all nodes, then it is going to use which type of address? Double F02 colon 1. So all nodes, all interfaces that uses IPv6 that are on the link. So this IPv6 address is equivalent to 224.0.0.1 of the IP version 4. Okay. Next. Now it says that all routers, here it is all nodes, irrespective of the devices. Here it is all routers. So for that, it uses what? Double F02 colon 2. No need to remember all these things. And it is similar to the IP version 4, 224.0.0.2. Then, as you know that we have discussed in the OSPF that the multicast address for the OSPF is what? 224.0.0.5 and 224.0.0.6. So here it is same only. Now you see double F02 double colon 5 double F02 double colon 6. This is for the multicast address of OSPF in the IP version 6. This is when you use IP version 4. This is when you use version 6. Same as for the RIP also. I told you know that we have a range RIP NG also. So for the RIP in IP version 4, the multicast address is what? 224.0.0.9 and here it is double F02 double colon 9. Then in the case of EIGRP, it is 0.10 and here it is A. As you know that A is also a 10 only. And for this DHCP relay agent, this is the value and we don't have the IP in the relay agent. Okay, so this is explaining you here that here we have global prefix, subnet, and interface ID is called as a host part. So set by whom? Regional Internet Registries, IANA or ISPs. Okay. Next is what subnet part, and these are set by whom? All these local engineers. That's why we have global prefix that is called as a network part, subnet, interface ID. Clear? Now we will be understanding this part, what it says, and how to get linked local address. We need to understand this part. Now, for example, I have taken a one PC, come to this PC, desktop, IP configuration, and see here. By default, IPv6 link local address is present. We have not configured it, right? So now we have to check how it is present. Now the link local address, right? Next, you have to check the MAC address of this particular PC. Come to this config, fast Ethernet. Then this is the MAC. Copy this and paste. Now you compare. See the last thing, 2C77 is present. Then here we have 4A55. Here we have FE55. But if you will see here, 4 is present. Between 4A and double five, between this 4A and double five, we have double F and double FE. Sorry, F double F and FE. It is present, no? So it means that this IPv6 link local address is being generated using what? MAC address of the device. Okay, and see how. Huh. See, first rule. First, it says that remove dot and add colon. This is the first step. What it is telling you, remove dot and add colon. From where you have to remove this dot? MAC address. Then remove this, write 0002 colon, then 4A double 5 colon 2C double 7. This is the first step. Second, add FF and FE in the middle. Add that 0002, then 4A FF colon FE double 5 2C double 7. Okay, this is what FF and FE we have to add. Next, third rule, third step. Invert the seventh bit. What it says? What it says? Invert the seventh bit. Now for that, you have to write the bit, then only you can invert that. So like if you will find here it is going to be 0. If I will write this 0 into the bit form, how many I will get? 4. Then it is telling you 7. It means again this 0 also I have to write to the bit form. So first 0, if you write, it is going to be 0, 0, 0, 0. Then here I have got 4 bit only. So I have to write here one more. So again 0, 0, 0, and 0. Now if I will write this and according to the rule I will follow. So what is the rule telling you? Invert the seventh one. Okay. So what is the seventh one? This is 1, 2, 3, 4, 5, 6, 7. Okay. So seventh bit is what? 0. Inverting means what? Make it 1. Inverting means if it is 0, make it 1. If it is 1, make it 0. So here I have got 0, so I will make it 1. Right? So when I will invert this, it means my value will also change. What is the new value I will get? 2. So now write this. Once we have inverted this, so now new value will be what? 0, 2, 0, 2, colon, 4, A, double F, colon, FE, double 5, colon, 2C, double 7. Till it is clear? Next, fourth one. Add FE 80 in the starting. Add that FE 80. Next is what? All this value we have to write. Okay. Now, last one more is left. What is that? Shortening of IPv6. Okay. So in this, what you have to remove? Only one thing is there, that is called the leading zero we have to remove. And this one, right? Done. Now you compare. This one we have solved and this one was given. They both are the same or not? Yes, it is applicable for every devices. This is how the devices gets linked local IPv6 address. Getting understood this concept? And same, this concept only we will be using for assigning the IPv6 address. Now see what happens. That as you are seeing here that this IPv6 is very long. So when you will assign from your side, there will be high chances of the error. Okay. And always you have to assign unique IP addresses to multiple different devices. So one option is directly you can assign. One more option we have that we can use here the concept like a extended unique identifier, EUI. In the concept of extended unique identifier, the same process is being followed. How we have got it here, link local IPv6 address, same thing will be done. In this, what will happen? That first 64 bit, that is the network part and the subnet part will be assigned by what? ISP. Host part will be taken from where? Again, MAC address. So now I am telling you the last host part will be taken from where? MAC address. So now you know that MAC address is going to be 48 bits. I am telling you 64 bits. So from where you will bring this extra 16 bits? FF and FEO. So in the case of extended unique identifier, there also will get last 64 bits of IPv6 address automatically from the MAC address, right? So same concept will be followed, how we have done with the link local address. What you will do here, in that MAC address, remove this dot with colon. Second step, add FF and FE in the middle. Then invert the 7th bit. And at last, instead, we will not add FE80 in that because that is what? My normal IP address, not a unique local address. Means local unicast address, right? So there will be no need to add this FE80 when you are adding, when you are writing the IPv6 address, complete IPv6 address. Getting my point? So one concept is called as what? EUI, that is called as what? Extended Unique Identifier. In this, last 64 bits of IPv6 address will be generated with the help of MAC address following the, so these are the steps. This is the fourth step it has to follow in the EUI. So in this EUI, we don't have to do anything. Just we will be given this command. Devices will take it automatically. In the case of routers. Whereas in the cases of the PCs, it is already present based on the MAC address. Clear? Okay, fine. So see here now. Now, what is the meaning of this link local? Why it is present here? See, IPv6 uses linked local address as a special kind of unicast IPv6 address. Okay. Now, what happens that these addresses are not used for normal IPv6 packet flow. These are not used for what? Normal IPv6 packet flows that contains data for applications. These addresses are used by some overhead protocols and for routing purpose. Now see here it is define you that IPv6 defines rules so that the packet sent to any linked local address should not be forwarded by any router to the other subnet. Means if any packet is being delivered to the linked local address, that has not to be forwarded by the routers further. So as a result, several IPv6 protocols make use of the linked local address when the protocol message needs to stay within the local LAN. Understanding my point? Then if that particular information has to be circulated in the LAN only, so it is going to send using the linked local address instead of sending to the private IP address or the global. Means it does not want to send this particular data information outside its own LAN. In that scenario, what is being preferred? Preferred to the unique local address. This one that is called as a link local address. Now it says that, for example, NDP, Never Discovery Protocol, which replaces the function of IP version 4R, uses the link local address. So who is going to use this link local addresses? NDP, Never Discovery Protocol. As I told you that here R will not be used. What is being used? Never Discovery Protocol, NDP. Okay. That's why it is called, or it can be used in the case of LAN environment, because we don't prefer this for the routable purpose. Okay. And this is how we have got it. So one is from EUI, last one is, and first one is like this FE80. Clear till here? See how to generate IPv6 address automatically. Okay. So for that, we need to at least give the network part. So for that, come to this particular router, say like give no, enable config is pasty. Now, what is the host name we will give here is router one. Now, interface number is what? G0/0. So you have to write here interface G0/0. Then when we write IP version 4, how we write IP address, right? But in this, we're using IPv6 address. So if you write IP address, it is not going to take it. It will always take IP version 4. So for that, we have to mention IPv6 address. Let's say I'm assigning here 20001 colon colon slash 64 EUI hyphen 64. What does it mean? It means here that I am telling that you have to generate last 64 bits from the extended unique identifier. That's why I've given the command 2001 double colon slash 64 EUI hyphen 64. Now, if you have given this and now you give here no shut and give exit. Now you verify. If you will give command do show IP interface brief, it is not going to show you. The reason? Because we have not configured IP, we have configured IPv6. How will you verify? Do show IPv6 interface brief. What is the IP we have configured? 2001 double colon, right? So it means till here is the network part and rest is what? Host part. And you compare this, it is going to be similar to the link local address. Why? Because link local uses the same concept, like an external unique identifier only. What is the differences between them? Just here we have added FE80 and here we have given the network part. Correct? No? So just we have configured and we have given EUI. So it is generating it from where? MAC address, last 64 bits. So if you have configured on this particular interface, so same we can configure on this interface also. So what is the IP we have given here? 2001 colon colon slash 64. Now, as you know that they should have in the same network. So same I will give 2001 colon colon slash 64. But as my router is changed, so MAC address will be changed. If MAC address is changed, again I will get a unique IPv6 address, right? So come to the second router as well. Enable config space T. Now, what is the host name? Interface G0/0. IPv6 address 2001 colon colon 64 EUI hyphen 64. This is the command. Okay, then you will give here no shut, give exit. How will you verify? Again, same. Do show IPv6 interface brief. And this is the IP that we have got. Right? So network part is same only and the host part is different.
Here, so it's showing up in this router, both ups. In previous router, it was showing one up and on.
Do show IPv6 interface brief. Now it is up. It takes time to get up. Okay, that's why. Now, one more thing. See, here we have a directly created IPs. If I have to do the routing, this side also I have to take one IP, multiple IP. So let me take 2002 colon colon 2 2/64. And this side I'm not using EY because this is the IP that I have given, right? No, correct? Now, if I have to take one more, let's say 2003 colon colon 3/64. It means two different IP, two different network. It is there, no? 2002 one network, 2003 one more another network. So we have to configure this both the IP where on the interface loop back. Okay. So come to this router. Second one, give here interface loop back and see how we can give this complete IPv6 address instead of giving /64 EY. So for that IPv6 address, then you will write 2002 colon colon 2/64. That's all. Here we have not written EY. So this is my complete IPv6 address. Okay, you will see also. So when you will elongate it, how many sets of zero you will get? How many numbers? One and two groups are there, no? So when you will remove, you will get six sets of zeros. Six. 1 minute. Do show IPv6 interface brief. This is the IP. What was the IP? 2002 colon colon 2. Okay. So can I write this 2002 colon 0000 colon? Hmm? This is the shortened version. This is the normal elongated version. Excellent version. Correct, no? So 1, 2, 3, 4, 5, 6, 7, 8. Total we know that we will be having 8 groups like this. So always when you will write this, when you have configure here, so it is in the shortened version. Okay. Done. So we have to configure one more IP. So come to configure space T. Interface loop back to IPv6 address 2003 colon colon 3/64. Give exit. Do show IPv6 interface brief. Configured. Now, when you will try to reach from the router first to this network, it will not be reachable because routing is not there. If you try to do ping 2002 colon colon 2, not able to reach. Right? Then we have to do here routing. So how we do? IPv6 route to reach where? Network address. Then you have to write what? Next hop. But for to write this next hop, first you will come to this router, copy, then come to first router, paste. Because this is very long. No, if you will write or if you will type, it is obvious some mistake will be there. So better to copy and paste. Done. Now you ping, do ping 100% it is correct. Same thing, we can try it for that also. One more we have IP route. What will be the command? Not IP route. It is going to be IPv6 2003 colon slash 64. Again, next to IP we have to write here. Copy this. Paste. Correct, no? Then to ping 2003 colon pinging. This is what? Static routing. Right now, remove both the routing now. Give no. And give here also no. Removed. Now we verify, do show IPv6 route. No route is present. Then this time what we will use? Default routing. IPv6 route to reach any network, right? It means any network means what? All zero. So can I write all zero like this? We can. Double quote. Okay. Slash any subnet mask, any prefix length, 0. Okay. And what is the next hop IP address? Best. Done. Do ping. Pinging. Pinging. Do show IPv6 route. Clear it is? Clear. It is not showing here, but it is explaining you that this is regarding the default routing. And why it is 0? Because we don't have any metric cost here. That's why it is 0. And what is the AD value? 1. Clear? So write down the command for this. So for a static routing, now first we have to how to assign the IP. For that you write interface, then interface number. So let me write with example only. IPv6 address. So how we have written 2001 colon 64 UI hyphen 60. Clear? Okay, so NDP uses certain concepts like a router solicitation. Solicitation. Asking for the device. So it's not asking to the devices for neighborship. Then what we have? Router advertisement. Reply from the route. So this can be helpful in the case of stateless auto configuration as well, where it is going to be based on this NDP only. One more we have for neighbor discovery and asking for the router for neighborship or to know about next router. Same, we have one more that is called as a neighbor solicitation and neighbor advertisement. Okay. To verify the reachability of the neighbor and identify the linked local address, we can say, or the MAC address. So one last part is left in the IPv6 that is called as a stateless auto configuration that we'll discuss now. Clear? So see the last one. Now again we'll take two router. So we are going to configure the IP on the one of the interface, whereas we'll not configure any IP on the other interface. It has to take it from the automatically. Okay. So come to this router. Enable config space t. Host name is R. So interface G0/0. Let's say we have to configure one IPv6 address 2001:4/64 UI-64. Okay, we have configured this IP. Now you give exit and you check do show IPv6 interface brief. This is the IP. Okay. One more thing you have to give here. IPv6 unicast routing and interface G0/0 IPv6 enable IP. Give exit. So we have got one IP on this. Okay, one more thing. No shut is there. No. Interface G0/0 and give it here no shut and give exit. Now come to the second one, CLI, give no, enable config space t. What is the host name? Router 2 and do show IP interface brief IPv6 interface brief. No IP has been configured, right? So next, first you will give IPv6 unicast routing, then interface G0/0 IPv6 enable, then IPv6 address autoconfig, IPv6 address autoconfig and give no shut and give exit. And now you give do show IPv6 interface brief. We have to enable that on this interface. I'm enabling the IPv6. I want to configure the IPv6 address. That's why.
This unicast only works on IPv6.
The stateless auto configuration feature. So we have configured the IP on this interface. We have not configured the IP on this interface, but it is going to get it from where? From the first one. Means what it will get from the first one? Network part. Because host part, again, it will take it from where? Its own MAC address. And this feature is called as what? A stateless auto configuration. Okay. So command for the stateless auto configuration we have to write now. Stateless Auto configuration is a feature of IPv6 where on one router IP has been configured, whereas on the other directly connected router, no IP has been configured using stateless auto configuration. Other router will get IP address automatically, right? So the configuration involves here. First, you will write IPv6 unicast routing, then interface and interface number. Okay, then IPv6 enable and IPv6 address auto config. Clear? This will completes IPv6. Just 1 minute. Yeah, so next topic is NTP, that is what? Network Time Protocol. Okay, now it works by synchronizing the devices to ensure that all the computers in a given network agree on a same time. Okay, now we have multiple devices. So all the devices has to be synchronized with the timing. Okay, so if they have to communicate, this have to respond at the same time. So it is a required in a communication over a network to show a seamless connection. For having a seamless connectivity, NTP is required. Okay. Now, for example, irrespective of the location of the devices, even if the devices is located at different geographical location where we have different time zones. So even we communicate that message reaches now only if you send at 5 p.m. IST timing, and if any other person is located in different countries at different location, so he's going to receive that according to his own time zone, right? But the devices has a seamless connectivity. We are sending now, receiving now, right? So it operates based on what? UDP. And what is the port number for this? 123. Okay. So there are different modes in the case of NTP. The modes are client mode, server mode, and broadcast mode. Now, what happens in the client mode? Our devices in the client mode is going to initiate a request to an NTP server to obtain the current timing. Means that devices is going to take it the current timing from the server. The devices that is going to collect the timing from the server is called as what? Client. Whereas one more is what? Server mode only. It means this is going to act as what? Server. So an NTP server that responds to a time synchronization request from the client is called as a server mode. Who is the client? Who is going to take the who is going to request the time from the server? The server who is going to reply. Fine. Now, apart from that, we have one more mode that is called as a broadcast mode. In this, what happens? It is independent of the client and server mode. Means it is not dependent upon the request. It says that NTP servers periodically sends the time updates to a broadcast address, and client configure to that listen to this broadcast address and can synchronize their clocks without sending individual request. One is what? One, in the client mode, devices will send individually requests to the server mode to obtain the timing from the server mode. In that scenario, server will reply. Whereas one more scenario is there where server does not require any request from the client. It keeps on sending the synchronized messages so that all other devices should be synchronized with the time. Right? No? So in the broadcast mode, what is not required? Request from the client is not required. And nowadays, what which one is most preferred one? The broadcast.
Meaning of synchronize.
Synchronize means what? Like working parallelly, equivalent timings. That's why synchronizations. Okay. So see, it says here that in never time protocol, peer mode, also known as asymmetric mode. It means we have one more mode: client, server, broadcast, and last is peer mode. Most preferred nowadays is peer mode. See, what it says that also known as what? Symmetric mode is a configuration where two devices establish a mutual relationship, right? And to synchronize their clocks. Unlike the traditional client server model, where one devices request time with other devices and provide it, whereas in the peer mode, what happens? Peer mode allows both the devices to send and receive the time updates and facilitating the mutual synchronization. Two devices are there, they both will synchronize their own times, irrespective of asking from the server mode or taking from the server. Directly, they both will be synchronized if they both are communicating. And this mode is called as what? Peer mode. And in, or we can also call it as what? Symmetric mode, not only the peer mode. Fine. Now see how it happens and what are the things is there. See, router, switch, and other networking devices are pretty much every device known in the IT world has a time of a day clock. What we have? Time of a day clock, right? Now you can verify also. If you will take a router, CLI, enable pro clock. When you're checking with the show clock, see it is telling you the timing. Now we will set the new timing here. Okay. So see what it is written that So for a variety of reasons, it makes sense to synchronize those clocks so that all devices have the same time of a day. And other than differences in the time zone, even in the time zone. Now, why it is important? See, for troubleshooting purpose, when you will check, it should show you that all will this timing, this was the traffic flowing. So while troubleshooting also, it is going to be very easy. That's why it is important for having this NTP. So the network time protocol provides a means for the NTP gives any devices to a way to synchronize their time of a day with a command, this one. What is the command? Clock set. Then you write the hour, minute, seconds, date, month, and year. So let us write that. So when you will give the command here, clock set, what it says, write hour, minute, and seconds. What is the hour? 12, let's say 40, 60, okay, 18. Next, date, a day of the month. What is the date today? 30th. Next,
9.
and we have given this. Automatically it is taking Tuesday today. Tuesday, no? Right? This is how you can set the clock time manually with a device. Now see, what is written? That in this NTP, we are going to have different modes. We have discussed the modes. Now we have certain conditions like a master and servers like this. Now one is NTP master. What this NTP master will do? It is telling you that NTP server mode, the devices act as only as an NTP server. When we have a server, if that particular server is acting like a server only, in this, it is not going to take it from anything from any other server, then this will be called as a NTP master and does not act as a client. Means you can consider we have a server. So we have manually configured a time on that server. So now if we have configured it the time, so it is responsible for sending the time. It is not responsible for collecting this time from any other server. So he is at the highest position now. As he is at the highest position, so this type of server will be called as what? NTP master. Getting? Means for this server, there is no any external control. He is not going to ask any other devices to tell me the timing, to synchronize the timing. That's why as it is not asking any other devices, it is called as what? NTP master. Then what we have? One is called as a NTP server. Now, why it is called as a NTP server? Because this particular server will be acting as a middleman. How middle? It will be asking the timing from NTP server. That's why he will act as a client now. And after that, he will be responsible for sending this timing to the other client also. And this time he will act as a server. Getting my point? So understand that let's say we have three different servers. 1, 2, and 3. And this is what? This is my master. This is server. And this is client. Okay. So this master will synchronize whom? Server. And this server will synchronize whom? This client. So now why we call it as a master? Because it is not going to take it from anything. No? This is not taking any timing or synchronization from any other devices. This is my final devices. That's why this is master. This is my intermediate devices. That is collecting the timing, sending further to the next devices. That's why this is server and this is going to be called as what? Client. Okay. So NTP server, what it says, NTP client server mode. Thus, the devices acts as both the client and server in this case. So first, it acts as an NTP client to synchronize time with the server. Once synchronized, the device can then act as an NTP server to supply the time to the other clients. Okay, so this is called as what? NTP server. And the last one will be what? Client. So it is explaining you that this is what NTP master, where it has got one timing. This is what NTP client, and this is what NTP client server. See what is the command that you have to give it on the router one. Where is router one? This is my client server. No, this is my client further. So you have to write NTP server and the IP address of that particular server. What is the IP? This one, 172.16.2.2. So this is the IP, right? So you are informing that, see, R1, you have a server, means your neighbor is a server that is called as an NTP server. He is having the IP as 172.16.2.2. You have to synchronize the timing from that particular device, right? Same as you are telling on the router to further that, see, for you also, if you have an NTP server and you have to obtain that timing from that particular server, and the IP of that is 172.16.3.3. And finally, router 3 is acting as a master only. So here we have configured as a NTP master and a number. Correct? Basic understanding we should have at CCNA table regarding the NTP, where we have to know about the modes. What are the modes we have? After that, if we have the modes, if we have certain such devices in a server, then how it will be acting, server, client, master, and how to set the clock in the NTP. Clear, no? Fine. So today we have completed IPv6 and network time protocol. Tomorrow we'll start with the DLAN. That's all for the day.